So we're on question 7. The diagram shows part of a curve 3 minus 2x squared together with its reflection in the lines y equals x, y equals minus x, and y equals 0. Find the area of the shaded region. Okay, well, what have we got going on with this? I think the first thing that I wanted to do with this is to try and work out a little bit of where some of these coordinates were, where some of these points were, and think about that. So I think actually probably in the exam, although it's not really encouraged, I would probably have drawn on the exam paper at this point, and I probably would have done this as the first thing I did. I probably would have done that. And that seems like a reasonable thing to do. I probably then would also be thinking, what is the graph 3 minus 2x squared? That's quite a crucial thing. So y equals 3 minus 2x squared. That's, thinking transformations of graph, that's an x squared graph that is reflected, so it's upside down, then stretched, then lifted up 3 units. Actually, that bit there is the original graph, isn't it? That's the original 3 minus 2x squared that has then been reflected in y equals x and y equals minus x and the y-axis. So that's all kind of quite helpful stuff. So the point C on there, that's quite a crucial point to think about. The point, that was good. The point C is the point of intersection of y equals x and y equals 3 minus 2x squared. That's what the point C is. And I want to find what that point is. So I'm going to do 3 minus 2x squared equals x, which gives me 0 is 2x squared plus x minus 3. There's no reason why I shouldn't use my calculator to solve that quadratic equation if I want to, because it's not a detailed reasoning question or anything like that. It does factorize though, doesn't it? That would be, what would that be? We need the 3 there and the 1 there, I think. Is that right? And that would give me a minus and a plus. So x is minus 3 over 2 and x is 1. Well, clearly at the point C, x isn't minus 3 over 2. So at C, x is 1. Minus 3 over 2, that relates to where this graph carries on and crosses the line down there somewhere, doesn't it? Down there somewhere. But that's not the point. Right. So that's the point 1. By symmetry, I think what I now did is I thought here is that curve. Here's the bit that I'm interested in up there. That's the point minus 1. That's the point plus 1. I'm not drawing it terribly well, but that's the curve that I'm after. So that shaded area, that relates to this shaded area here. That is the integral between minus 1 and plus 1 of 3 minus 2x squared. Actually, a little bit careful about that, isn't it? Because if I do that, I would get the area underneath it as well, wouldn't I? So I'm going to just watch out for that bit as well. So I'm going to do that, and I'm going to take away the area underneath it. So I'm going to take away this red area here, and that red area is 2 by 1. So that's because that's the point 1, 1, isn't it? So that's taking away 2. That's what I'll do at that point. So that's going to give me 3x minus 2x cubed over 3 between
why taking away 2?
Minus 1 and 1. Take away the 2. So if I do that integral, it gives me all the area underneath the curve, or between the curve and the x-axis.
Yeah.
But I only actually want the bit that's shaded in green there. And that area underneath it, this area here, has an area of 2. If I do the integral, I'd get all of it. So I'm going to subtract that area so that I just get the green bit. That gives me 3 minus 2/3, take away minus 3 minus 2/3, take away 2, I think I end up with, what do I end up with there? 6 minus 4/3 minus 2, which is 8/3. Okay, now I just need to put the whole thing together. So looking at my original diagram, I've now established that that area there is an area of 8/3. There are 4 of those green areas. There's one there, there's one there, and there's one there. And there's a red square in the middle, and the red square is 2 by 2. So that has an area of 4. In the middle of that. So if I put all of that together, my total area is 4 lots of the 8/3 plus the 2 by 2 square, and that gives me 44/3 as being my grand total of the area. And that's maths. It was just about breaking it down into smaller bits, wasn't it?